with metal, right? These reactions are very, very important in chemistry. Okay, so let's see one by one. We will see each and every type of reaction, and we will basically understand the mechanism first, right? So first reaction is nucleophilic substitution reaction, right? So nucleophilic means nuclear. Basically nucleophilic means nucleophile, right? And nucleophile is nucleus loving, right? Positive loving. Okay. So basically they are electron rich. Nucleophile are electron rich. So that's why they just love nucleus. They just love the positive one. Okay, so the nucleophilic substitution reaction. So it's a reaction in which a group of substrate, and now there are two words, I have discussed it in the previous class, substrate and nucleophile, right? In this type of reaction, there are two terms, substrate and nucleophile. So substrate kya hota hai? So they are basically the organic reactant molecule, right? And because we are discussing about the haloalkane, so here the substrate is haloalkane, your RX. Here the substrate is your RX, haloalkane, right? So that's the substrate. Now the nucleophile. Nucleophile, we know that nucleo means nucleus, right? And phile means loving. So nucleophile are nucleus loving. Obviously, they are electron-rich species, so that's why they attack the positive one, they attack the nucleus. They just love the nucleus, right? So obviously, they will have negative charge over here because they are electron-rich. They are electron-rich species, and they just attack on carbon atom. They attack on carbon atom because they are electron rich, and carbon atom is a electropositive element. So that's why that nucleophile, it always attack on the carbon atom. Okay. So what is nucleophilic substitution reaction? So nucleophilic substitution reaction is basically a reaction in which a group of substrate, right, is replaced by a nucleophile. Nucleophile, so that's why we call it as a nucleophilic substitution reaction. That nucleophile, it replaces that substrate, right? And it will give you a product. So that's why it is known as nucleophilic substitution reaction. Got it?
Yes, ma'am.
See this, the general reaction. Suppose this is your RX. This is your substrate basically. Right? This is RX is your alkyl halide. So basically it is a substrate. Right? When you add the nucleophile over here, when you treat the substrate with a nucleophile, so what will happen? Obviously, this nucleophile is a electron-rich species, and it will attack the carbon atom, right? So it will attack the carbon atom of this alkyl group, right? And you know very well the halogen group are good living group. They are good living group, so they leave the molecule. So they just leave the molecule and you will get R nucleophile plus your X minus, right? So the halogen group will be left and you will get there will be a new bond formation with this nucleophile with the alkyl group. Okay. So in SN, and basically how we just denote the nucleophilic substitution reaction. So capital S, and in the subscript we just write N, capital N. That is your nucleophilic substitution reaction. Okay, so in nucleophilic substitution reaction, one base is replaced by the another base. Okay, one base is replaced by the another base, and the incoming base, which is incoming over here, so that is known as nucleophile, and the outgoing means the living group, right? Outgoing, and here is the halogen group is the outgoing group, so they are known as living group, and halogen group are good living group. Okay, so incoming base is called nucleophile, and the outgoing base is called living group. Just remember that. Okay, so we have discussed some questions over here. So see over here. So CH3, CH2, Br when it treats with Cn minus. So you can see Cn minus is a nucleophile and this is your substrate, right? So what will happen? This Cn minus, it will attack the carbon atom, right? That carbon atom to which the halogen group is attached, right? So you can see the halogen group is attached to this carbon. So it will attack on this carbon, and this is a good living group, so it left, right? And you will get cyanide over here. The Cn minus the cyanide, it will attach over here and you will get this product. Okay, so what is nucleophile here and what is the leaving group here? So nucleophile is Cn minus and your leaving group is Br minus. Okay, similarly on the second, see the second one, NO2. NO2 will have the negative charge, right? Means it is a nucleophile. And what is the substrate over here? Substrate is this, right? So what you are going to do, see the halogen group. Halogen group is attached to this carbon, right? So it's very simple. Just attack the nucleophile attack on this carbon, right? On which the halogen group is attached. So the halogen group is a good leaving group. So it will left the your molecule, right? So incoming nucleophile, it will attack to this carbon. It will be attached to this carbon and it will give you this. Yeah. So here again, the nucleophile is NO2 minus and leaving group is Cl minus. Yeah. So similarly, you can do the same. You just have to check which one is the nucleophile and which is the, what is the alkyl group over here, right? And the halogen is attached to which carbon. Okay. So just replace that halogen group. Okay. So you just left halogen group will left and just attach that nucleophile on the carbon, carbon which is attached to the halogen group. It's very simple. Okay. Similarly, okay, let's do some more question based on this. You just have to tell me what is the product which is formed. Suppose it's the benzene and here chlorine group is attached. And I'm giving the NaOH. I'm just treating it with NaOH, sodium hydroxide. Okay, so just tell me the product. Tell me the product. And what is the nucleophile over here? And what will be the leaving group? Okay, in both the questions, just tell me the product and what is the nucleophile and what is the leaving group.
NaCl plus OH.
Yeah.
The nucleophile is OH minus
Yeah.
and the leaving group is Cl.
Yeah. So what will be the product?
NaCl.
Okay.
NaCl plus OH.
NaCl plus OH. Yeah. You basically this OH will be attached. This chlorine will be replaced by this OH group, right? OH यहाँ पे attached हो जाएगा. It is nucleophile. It will attach to this carbon center and this leaving group is just left. Okay, so leaving group left hoga, so it will give you Cl minus, and we have Na plus. So they will form, they will just combine, and they will give you NaCl. Right. So basically, this is the major product. This is the major product, and this is the byproduct, sodium chloride. Yeah. Okay, Moniba will tell me the second one. Tell me the answer for the second one.
One minute.
Yes.
Br is the leaving group
Yes. And what is the
and
nucleophile here?
hydrogen.
Are you sure? Hydrogen. First, just dissociate this. So H2O, water, it will dissociate to form H plus and OH minus, right? And we know that nucleophile, it has a negative charge over here, right? Negative charge hota hai nucleophile pe. So OH is a nucleophile, not hydrogen, right? So OH is a nucleophile. It will attack to this carbon center, and from here, the bromine will leave. So you get this as a product. Here, the OH group will be attached plus your HBr, right? H plus, it will combine with your bromine, and it will give you HBr. So that's a product. That's how you have to write the product. Clear?
Yes, ma'am.
Okay. We have also discussed that in any nucleophilic type of reaction, because that's a basically a substitution reaction, right? So you can see the bond, there will be two steps, okay? Or sometimes the nucleophilic attacks, basically this reaction, it consists of a breaking of bond, breaking of the Rx bond, and the formation of new bond with the nucleophile, right? So this breaking of bond and the formation of bond, sometimes it can takes place in the single step, and sometimes it can takes place in the two steps. Okay, so accordingly, there are two types of reaction: SN1 type of reaction and SN2 type of reaction, right? So first you can see over here, this is Rx bond. ये क्या हो रहा है? ये break हो रहा है. When the Rx bond will break, so we have discussed, right? So obviously this has an alkyl group, means carbon chain, right? So obviously when this bond will break, so obviously this halogen will get negative charge and this alkyl group will get positive charge, right? And we know that on nucleophile there is a negative charge, so obviously it will attack this the opposite charge, which is alkyl group, the carbon of alkyl group. So this bond will broken. First, this bond will break, and the new bond will form with the nucleophile RNU, right? And this is your leaving group. This will leave the molecule. Okay, so see here. Yeah. So basically, there are two types of reaction, two types of nucleophilic substitution reaction. First one is your unimolecular, and the second one is your bimolecular, right? Unimolecular reaction is your SN1. One क्या कहता है? One denotes the unimolecular. One means uni, right? Unimolecular means molecularity is one. Molecularity is one. Okay, so basically, uh, if you don't know the what is molecularity and what is the order, so let me discuss here. This is the topic of chemical kinetics. So basically, molecularity is the total number of species which are reacting to form the product. Okay, which gets in which all the species, they just combine simultaneously, they just collide simultaneously. So to give the effective collision, so that is if molecularity. For example, if two molecules of A, it combines with B, right, and it will give you C. So if I ask you what is the molecularity in this reaction, so you can see two molecules of A, two species of A, right, it's reacting with one species of B. So the molecularity is 3. Molecularity is 3, right? So just remember. So if the molecularity is 1, right, means only one species here is reacting. So it is a unimolecular reaction. Yeah, unimolecular reaction means molecularity is 1. Okay, so SN1 reaction is your unimolecular type of reaction, and SN2 type of reaction is your bimolecular. This two, it denotes a bi, right? So bimolecular type of reaction. Okay, so see, this bimolecular type of reaction, it occurs in the single step, right? So it's don't be confused in that. So it's a bimolecular, so it will have two steps. No, right? So this two, it just denotes the molecularity of the reaction, not the step, right? So basically, SN2 reactions kya hote hain? They are single step reaction. What happens? The breaking of bond and the formation of bond. right? Formation of new bond and the breaking of old bond, it happened in the same step, one single step. So that's why it is known as SN2 type of reaction. You can see here's a nucleophile, right? So nucleophile just attack the alkyl group, and at the same time, this is a good living group. Halogen is a good living group, so it left, right? It just leaves that molecule, and the new bond is formed with the nucleophile. So you can see this breaking of bond just break, this Rx bond is break, and this new bond is formed with the nucleophile. New bond is formed, right? So basically the bond formation and the bond breaking, it just takes place in the single step. So that's why it is a bimolecular SN2 type of reaction. And what is the rate of reaction? So you can see here the rate of reaction, because why it is bimolecular over here. So you can see two species are there, one nucleophile, and the second one is your substrate, right? So two species are reacting with each other. So that's why it is a bimolecular type of reaction. Okay, and the rate of reaction is directly proportional to this nucleophile as well as this substrate. So in the SN2 type of reaction, bimolecular type of reaction, the rate of reaction, it depends on the substrate as well as nucleophile. Substrate as well as nucleophile. Just remember that. Okay, so this is a case of SN2 type of reaction. Now see, what is SN1 type of reaction? So in SN1 type of reaction, we know that it is a unimolecular type of reaction. So basically this happens in the two steps, right? The reaction mechanism has two steps. The reaction proceeded two steps. So basically first step क्या होता है? The formation of carbocation. The formation of carbocation or the breaking of Rx bond, you can see. This bond just break, right? So we know that when this bond break, because halogen are the electronegative atom, so it will acquire partial negative charge, and on the alkyl group, carbon of the alkyl group, it will have it will acquire partial positive charge, right? So this bond will break, and basically it will form carbocation, right? So SN1 type of reaction, it first forms the intermediate, and intermediate is a कार्बोकटायन. कार्बोकटायन का फॉर्मेशन होता है फर्स्ट स्टेप में. Okay, so first step is always the formation of carbocation, right? Carbocation, and this living group just left. Now what happens in the second step? Because carbocation, we know that it is very reactive, right? So what happens, this nucleophile, it is because it is nucleus loving, right? And you can see यहाँ पे positive sign है, right? Carbocation, right? So this nucleophile, it just attack on this carbon center, right? On this carbocation. So, and it will form a new bond with nucleophile, RNU, and it will form the product. So basically, SN1 type of reaction, it has two steps. First step is the formation of carbocation, and the second step is the attack of nucleophile. Got it?
Yes, ma'am.
Okay, and you can see over here, because it's a unimolecular type of reaction, right? So this rate of reaction is only dependent on the substrate, not on the nucleophile, right? Because nucleophile second step में, yeah, one more thing. This first step is the, you can say it's a slow step. It's a slow step, right? But the second step is a fast step, because this, you know very well, the carbocation is very, very reactive, right? बहुत ही reactive होता है, तो nucleophile just attack करता है and it will form the product. But the first step is the slowest step. And we know that we have uh, studied in the chemical kinetics that the rate of reaction, it just depend on the slowest step. Rate determining step कौन सा होता है? Slowest step, right? So slowest step is the rate determining step. That's why the rate of reaction is directly proportional to the substrate only, not on this. Okay, so this is the case of SN1 type of reaction. So clear? These are the main points or difference between these two, SN1 and SN2 type of reaction. Okay, now we will see both the reaction in details. Okay, So first type, it refers to unimolecular nucleophilic. First, try to understand, then I will give you time to make notes. First is, it refers to the unimolecular nucleophilic substitution reaction. Okay, second point, a reaction in which the rate depends on the concentration of substrate only, right? In the SN1 type of reaction, because we know that the rate determining a step is the slowest step. And slowest step कौन सा था? Basically the substrate wala step, right? The formation of carbocation and the breaking of CX bond, RX bond, right? So the reaction in which the rate depends on the concentration of substrate only means the haloalkane over here. Okay, so the substrate here is haloalkane. So the rate of reaction depends on the haloalkane only. So that is known as SN1 reaction, right? So rate is directly proportional to Rx, concentration of Rx. If the concentration of haloalkane increases, the rate of reaction also increases. Okay, and we know that if we just remove the this sign, proportionality sign, so you will get proportional constant over here. This is K is your rate constant, right? What is K? So K is your rate constant. And what is the, for SN1 type of reaction, order is 1 and the molecularity is also 1. You can see what is the charge over here. So when you write on the rate reaction, so here this is 1, right? So order is 1. Order is 1 and molecularity is also 1. Okay, let's understand the mechanism. Okay, first try to understand the mechanism. उसके बाद आप लिखोगे. Okay, see. Basically, mechanism is very, very important for both the reaction for SN1 also and for SN2 also. First, try to understand the mechanism. Okay. So basically, first step is always, because SN1 reaction, we have seen that it occurs in 2 steps, right? SN1 reaction, 2 step mein hota. First step is always a formation of carbocation, right? Means the breaking of CX bond, breaking of CX bond, or the formation of carbocation. Yes? Yes, Jubita, is there any doubt?
No, ma'am.
Okay, okay. You just turn on your mic, that's why. So
Yeah, ma'am.
first step is breaking of CX bond. Okay, suppose if there's a molecule CX, right? Here's X halogen, any halogen is attached, and 1, 2, 3 I have written for the ease of understanding. Suppose 1, 2, and 3 is any group which is attached over here to this carbon, right? So suppose it's CH3, CH3, and CH3, any group. So I have written 1, 2, 3, right? Because मुझे कुछ यहाँ पे समझाना है, explain करना है. So first step will be the breaking of CX bond, right? So just break this bond, you know very well. So it will have, when this bond will break, so due to the high electronegativity of halogen, so halogen will acquire negative charge and this carbon will acquire positive charge, right? And this is the slowest step. This is your slowest step. So carbocation, right? So the formation of carbocation, when the bond will break, it will carbon will acquire positive charge and this X will be leave, right? Halogen left कर देगा group को. Okay, first step is done. The formation of carbocation हो गया. Now, because we know that carbocation is very, very reactive, right? So what will happen? This will be the fast reaction. Second step will be the fast reaction. When you compare the first and second step, the second step is always a very fast reaction, and the first step will be the slowest step, and that basically determines the rate of any reaction, rate of this reaction. So second step, the attack of nucleophile. Now see, this is our structure. See, this is our carbocation, right? Which is formed in the first step. Okay. So one position, see the position of this branching or any substituent, you can say 1, 2, and 3. Suppose these are the 3 substituent over here, which is attached to this carbon. Okay, so and this is carbocation. Now this nucleophile, there are 2 cases here. Nucleophile can attack from the front also, and it can attack from the back also. In both the cases, we just got the different product. So suppose if nucleophile just attack from the front, see, The nucleophile red color से जो मैंने show किया, that's the front, right? So when the nucleophile, when when it attack from the front, right? So front में attach कर दो on the right side of this carbon. So okay, so the nucleophile will attach to the this carbon, right? From the right side. See, the right side of the carbon is nucleophile. When the nucleophile attack the carbocation from the front, okay, so that you will get the retention product. You will get the retention product. Okay, so retention product is basically a similar arrangement, or you can see the arrangement of substituent is same as that of the substrate, as same as this substrate, right? So substrate के similar होगा तो that is a retention product, means the arrangement orientation is same. Arrangement of molecules is similar to that of the substrate. So that is a retention product. Okay. So, and there is another case in which the nucleophile can attack this carbocation from the back side also. Okay. If the nucleophile attacks from the back side, what will be the product? So the carbon, the nucleophile will be attached on the left side of the carbon. Okay, left side से attach हो जाएगा. So in this case, you can see this is your inversion product. What does inversion mean? So it's just like a inverse. You just have to inverse the substituent. आपको inverse कर देना है जो आपका substrate का orientation था, right? Substrate का जो orientation था, just inverse that orientation and you will get the inversion product.
Ma'am,
Yeah.
ma'am, can I leave the class? I have the chemistry need class now.
Okay. So you don't know that your class timing is for till 10:30?
No,
Jyotita?
ma'am. No, ma'am. They said to join the class right now.
Okay, no problem.
The timing is different in both the links. That's why. Yes.
Okay, you can join.
Thank you.
Okay, see, Moniba. So basically, in SN1 type of reaction, you will get racemic mixture. Racemic mixture means 50% inversion product and 50% retention product you will get. Okay, so just difference between these inversion product and retention product, just remember when the nucleophile attack from the front, right, front side, the orientation is very much similar to that of the substrate. Okay, you will just आपको similar orientation लिख देना arrangement, right? Just like your substrate. But when the nucleophile attack from the back side, the arrangement, the orientation of molecule is different, right? It become inverse, right? It become inverse. So from here, the nucleophile is attached, right? Nucleophile को यहाँ से attach कर दो to the left side of the carbon, and you will get this type of product. Okay, so that's the inversion product. So basically in SN1 type of reaction, we get the racemic mixture. And what is racemic mixture? So racemic mixture is the uh, inversion, 50% inversion product and 50% retention products, right? Basically, the mixture with 50% inversion product and 50% retention product is called the racemic mixture, right? And this process in which we get the inversion and retention product, this whole process is known as racemization. Racemization in which we get the racemic mixture. Clear?
Yes, ma'am.
Okay, and SN1 mechanism occurs via intermediate carbocation we have seen. First step is always the formation of intermediate, which is carbocation, right? And the rate of SN1 reaction is directly proportional to the stability of carbocation, right? Stability of carbocation, and just tell me which carbocation is more stable. I just explained it in the previous class, I think. Okay, आपने ही question पूछा था why this is stable and why this is not stable. So just tell me which carbocation is more stable, 3 degree, 2 degree, 1 degree.
3 degrees.
Yes. Yeah. So in SN1 type of reaction, the order of reaction will be in 3 degree में सबसे fast होगा, then 2 degree, then 1 degree. Why? Because this reaction, it occurs via carbocation formation, right? And we know that rate of SN1 reaction is is directly proportional to the stability of carbocation, right? So stability of carbocation, so the 3 degree, 2 degree, and 1 degree. Just remember that. Now you can write. Uh,
Mom, can you slow down?
And can I scroll down?
Yes, ma'am.
Okay, just quickly write down.
Mom, can you scroll down? Mom, can you scroll down?
It becomes quite messy, so you can write it clearly.
Mom, can you scroll down?
Yeah.
Done.
Okay, just write down the mechanism and try to do it by yourself. Written the mechanism?
Yes, sir.
Okay. Okay, let's do the mechanism for the SN2 type of reaction. Okay, right on the first point, for it refers to bimolecular nucleophilic substitution. The reaction in which rate depends on both substrate, means haloalkane over here, and nucleophile, is known as SN2 type. And what will be the rate? So rate is basically directly proportional to your substrate Rx as well as your nucleophile. The rate is equals to rate constant Rx and nucleophile. So from here you can see that the order will be equals to 2. It is a basically second order reaction. And again molecularity will be 2 because two species are reacting. First one is your haloalkene and the second species is your nucleophile. That's why the molecularity is, because it's a bimolecular type of reaction, it's molecularities. And let's talk about the mechanism. It has a quite simple mechanism. So basically, what you are supposed to do, so you know very well, this is a SN2 type of reaction. So basically, has a single step. The reaction proceed in single step, means the formation, breaking of bond and the formation of bond both in the single step. Let's write this. The breaking of your CX bond and formation of carbon with nucleophile Cu bond, or you can write RNU bond also. Takes place simultaneously in a single step. And yeah, basically, the single step, it consists of a transition state. Let's see. For example, if I write CX, right, and again I'm writing the same thing. 1, suppose it's 2, second, and it's 3. It's a third group over here, right? Suppose it can be your H group or any CH3 group or any alkyl group. Okay, so what happens? First, the nucleophile come and it just attack on this carbon atom, right? On this carbon atom. So again, so in the same step, what happened? This bond will break and it will acquire, you know, very well, because this is electronegative. So the bond will, this halogen group, it just have acquired the partially negative charge and this carbon will acquire partial positive charge. Okay, so now it has basically, it has a transition state. This reaction occurs via a transition state. So the carbon, here the first position, first group, second, and the third, right? Now you can see over here, this is the new bond formation, where the nucleophile is just attached to this carbon center. I am just showing the bond which has to break by the red color, right? Right. So you can see over here, this is the old bond with the CX bond is the old bond, and this is the CNU bond. This is a new bond. So what will happen? This is basically a transition state. This is the transition state. Right. And this transition state, this is very unstable. So due to the instability, what happened? This halogen, it will just left, right? This halogen, it will left, and you will get a product, which is your the nucleophile again on the same position, carbon here and on the here, one, two, three, right? Plus your X1. Yeah, so can you please tell me, Muniba, which products is this? Inversion product or retention product? What we call this product as? Just see the substituent 1, 2, and 3 position and just compare it with the substrate and just tell me which product is this, inversion product or retention product?
Inversion.
Yeah, very good. Okay, so you can see this is 1, 2, 3, right? So basically, this is your inversion product because nucleophile kahan se attack kar raha hai? On the back side, right? On the back side nucleophile attack. So you can see you can see you can compare, right? Basically, just compare the product with the substrate. Okay, so you will see the difference in these two. Basically, this is the inverse of the substrate. Okay, so the product is basically the arrangement is orientation is just inverse of the substrate. This is your 100% in this process in SN2 type of reaction, the product is 100% inversion, right? You don't get the racemic mixture, but you inversion product 100%. Okay, the product is 100% inversion. So that's the difference between the SN1 type of reaction and SN2 type of reaction. Right? SN1 में आपको क्या मिलता था 50%, you just got the racemic mixture, 50% inversion product and the 50% retention product. But here, in the case of SN2 type, you just got 100% inversion product. Okay, and this reaction basically occurs via transition state, and we know that transition state is basically a very weak, right? You can say stable, unstable होते हैं transition state. So that's why this living group is just left the molecule, and you will get the product 100% inversion product. Yeah, right. So basically, this will have a partially negative charge, and this OH group, which is nucleophile, it will have a partial positive charge over here. Similarly, if I give you some example, so just try it by yourself and just write down the mechanism and just tell me the answer. Question, suppose CH3, right, plus NaOH. Okay. Now just tell me what is the product and also write down the mechanism. Write down the mechanism of the reaction. First, tell me the product. What will be the product here?
CH3 will bond with
Yeah.
OH.
Yes. Okay, so why you're a little bit you are a little bit confused, I think. So you just have to check it, right? The reagent here is NaOH, right? So Na plus and OH minus, right? And जो negative वाला होता है, that is your nucleophile. So this nucleophile will attack on this carbon and this will remove, right? So you will get CH3OH. Now here's a Na plus and Br minus. Br minus will be removed. So they will combine together and they will form NaBr. Okay, so the final product is CH3OH and NaBr. Now you will get 100% inversion, right? यहाँ पे क्या मिलेगा आपको? Inversion product मिलेगा. Let's see how. So let's see the mechanism first. So This is your CH3Br. So can we write CBr and there are 3 hydrogen. So I'm just writing H. The another orientation. This is H and yeah, this is a third H. Right. Okay. Now this, what is a nucleophile here? The nucleophile is OH minus, so it will attack on the back from the back side. So it will attack, right? And this bromine, it will acquire partially negative charge and this will acquire partially positive charge. Now write down the transition state. Transition state will be one hydrogen over here, hydrogen, hydrogen, and this is the new bond which is formed with the OH, and I'm just showing the old bond, the bond which we have to break by this here. Okay, so you can see over here, this will have negative charge, partial negative charge, and this will have, you can, no need to show this, no problem. Okay, just what you're supposed to do, this is a transition state, and you know very well it is unstable. And bromine is a good living group, right? So just bromine will left out, and you will get the product OH over here, C, hydrogen here, one hydrogen here, and one hydrogen here, plus Br minus, right? So that's how we just write down the mechanism. Got it? So just try to understand the mechanism. Okay. First, try to write down the reaction first, and after the reaction, just try to write down the mechanism. Sometimes they ask you how write down the mechanism of this reaction. So you have to write down all the steps you have to show. If it is SN2 type of reaction, so you just show the one step reaction, and one step it occurs via transition state, right? So आपको transition state भी दिखाना होगा, which bond is the new bond, right? And which bond is the old bond. Old bond को just break down the old bond, and the new bond will be formed. Okay, and we know bromine is a good living group, so just it left out from the molecule and you will get the product. Yeah, and in this case, you will get a 100% inversion product. Inversion product 100%. Yeah, got it?
Yes, sir.
Right on the next point. So in SN2, the attack of nucleophile is always from the behind. From behind. And we know that जब behind से करता है, behind means from back, right? So from back से करता है, तो always you will get 100% inversion product. Inversion product. And yeah, just one thing, remember the rate of SN2 reaction is inversely proportional to the bulky group on alpha carbon. So that's very important. The rate of SN2 reaction is inversely proportional to the bulky group on alpha carbon. And you know what is alpha carbon? Suppose this is bromine group. The halogen group, which is attached to this carbon, this is your alpha carbon, right? The halogen group just attached hai, right? So that is your alpha carbon. And alpha carbon पे the bulky group, if there is a bulky group over here, the bulky substituent on the alpha carbon, then more the bulky group, less will be the SN rate of SN2 reaction, right? अगर ज़्यादा, suppose, for example, if I write, okay, this, or if I write, okay, just tell me in which the rate of SN2 reaction is fast. See, because we know that the rate of SN2 reaction is inversely proportional to bulky group, which is attached on the alpha carbon. Now see, what is alpha carbon? We know this halogen group is attached to this carbon. So this carbon is known as alpha carbon, right? So you can see that on alpha carbon, there are 3 bulky groups, C5. H9CH3 and C2H5. But in this case, right, तो यहाँ पे bulky group ज़्यादा attached है alpha carbon पे, means for this the rate of SN2 reaction यहाँ पे क्या होगा, less होगा, right? It decrease the rate of reaction, slow होगा यहाँ पे rate of reaction. But in this case, there is no bulky group, right? There is no bulky, only hydrogen is there. So obviously the rate of reaction इसमें fast होगा. The rate of reaction of SN2 reaction is fast in this than this, right? If I say A or B, so B में ज़्यादा होगा fast rate of reaction than A. Okay, so just remember the rate of SN2 reaction is inversely proportional to bulky group, right? Heavy bulky group लगा हुआ है ज़्यादा तो rate of reaction will be slow. Okay, so just remember that. Next point, just write down. So SN2 occurs via transition state. In SN2, we get 100% inversion product. Why 100% inversion product? Due to backside attack. Due to backside attack of nucleophile. Here, let's do some, let's see some examples. Examples of SN2 reaction. Suppose I'm writing CH3Br. Now, if I just treat this CH3Br with KCN, so just remember the CN is an ambidentate nucleophile. You know what is ambidentate nucleophile, Muniba?
Yes.
Yes, tell me. What is ambidentate nucleophile? Just define it.
They have more than like two nucleophilic centers.
Yeah, basically they have more than one donor site, right? For example, this is CN, right? So CN can attack from the carbon also, and it can also attack from the nitrogen side also, right? So this is a ambidentate nucleophile. So ambidentate nucleophile is the nucleophile which have more than one donor site. Okay, so that's a ambidentate nucleophile. जैसे CN minus हो गया आपका, your NO2 minus हो गया, AgNO2. These are some examples of ambidentate nucleophile which has more than one donor site, right? They can attack from more than one site. Okay, in the case of like cyanide, CN, right? So from suppose this is CN, so this is an ambidentate nucleophile. So if it attacks, suppose if it attack from the carbon, right? So it will give you CH3CN, right? So we know that this bromine will be left and you will get KBr. अगर ये cyanide की तरफ कार्बन की तरफ से अटैक कर रहा है, because this is ambidentate nucleophile, so more than two, there is two attacking site. So if this cyanide is attacking from the carbon center, so you will get this methyl cyanide. This is your methyl cyanide. But what will happen if it attack from the uh suppose if I give you AgCN. So in this case, this cyanide Basically, it attacks from the nitrogen center and it will give you CH3NC. CH3NC means your isocyanide. This is your isocyanide. So you can write methyl isocyanide. Plus what will be the byproduct? So AgBr. Okay, so that's the two cases of ambidentate nucleophile. If it is AgCN, so in this case, this cyanide will attack the this carbon center with the nitrogen side. Nitrogen will be the donor side or attacking side, and in the KCN, so it will attack from the carbon center. Suppose another examples. Let's see. If I give you CH3ONA, now just tell me the answer. CH3ONA. This is the reagent here. Basically, nucleophile. Now just tell me what is the nucleophile in this? CH3ONA, which will acquire positive charge and which will acquire negative charge over here. Hmm? Yeah, see, it's very easy. Obviously, sodium can,
CH3.
yeah, CH3O minus and Na plus, right? Because sodium is a metal, right? Metal पे हमारा क्या आता है? Positive charge, and on the other CH3O minus. Okay, so obviously the nucleophile here is CH3O minus, right? So what will happen? This will attack on this carbon and this bromine will left. So basically you will get the product will be the ether, right? CH3O CH3, right? You can see this is your ether plus NaBr. Yeah, and this reaction is basically known as Williamson synthesis, right? When you use CH3O Na, right? When you give, basically it is a preparatory method of the ether, right? From your haloalkene. So this is basically this is your Williamson synthesis. This is Williamson synthesis. Yeah. So these are some examples. Now let's see what are the factors that affect the SN1 and SN2 type of reaction. Okay, write down factors affecting SN1 and SN2. Okay. First factor is nature of substrate. Nature of substrate. Second, nature of living group. Nature of living group. Whether the living group is good living group or bad living group, whatever. So effect of solvent. Yeah, so there are three factors on which the SN1 and SN2 reaction depends. Okay, one by one we will discuss. So write down. First is nature of substrate. Yeah, so in this, first we will talk about the reactivity of SN1 reaction. Write down reactivity SN1. So we know that the SN1 reaction, it occurs via intermediate carbocation, right? So, and we have discussed that rate of SN1 reaction is directly proportional to the stability of carbocation, right? And we know that the stability, 3-degree carbocation is more stable, right, than 2-degree than 1-degree. So the rate of SN1 reaction will be more fast in the 3-degree than 2-degree, and sometimes in some conditions basically hota nahi hai, but in some rarely it happens in the 1 degree also, right? So just remember the rate of reaction you can write as SN1 occurs via intermediate carbocation. So the rate, or you can say reactivity also, reactivity depends on stability of carbocation, right? And we know that rate of SN1 is directly proportional to the stability. So therefore, rate of SN1 reaction, the order is basically 3 degree, then 2 degree, then 1 degree. And yeah, just remember, carbocation is highly stabilized by delocalization of charge, right, due to resonance. So that's why benzene, जो भी benzene ring होगा, right, more the benzene ring and more the double bond, more will be the resonating structure and more will be the delocalization of charge, right? So due to the delocalization of charge, what happens? The carbocation becomes more stabilized, more reactive. Okay, so basically due to this reason, the benzyl halide, right? In benzyl halide, what we see, just a second. Yeah. So what I said, carbocation is highly stabilized by delocalization of charge. Why? Due to the resonance. Yeah. So suppose I just I just said that what will be the order or rate, or you can say reactivity of SN1 reaction will be सबसे ज्यादा बेंजाइल में होगा, बेंजाइल halide. After that 3 degree, just remember. After that, sometimes 3 degree and alkyl halide, sometimes both. Sometimes in some conditions, 3 degree carbocation is more stable than allylic structure, or they mostly both are equal, right? Order could be equal. So allylic halide, then your 2 degree, then 1 degree. Just remember this sequence. This is very important. This is very important. Benzyl, then 3 degree, then your allylic one, then your 2 degree, then 1 degree. Okay, let's see why. So suppose you know the benzyl halide is what? When the halogen atom is attached to the sp3 hybridized carbon, then this sp3 hybridized carbon is attached to the benzene ring, right? Now this is a benzylic, so SN1 type of reaction, it occurs via carbocation formation, right? So when this halogen it will remove, what will happen? It will form carbocation, CH2 here plus charge, right? Now we know that this benzene ring, it's basically it shows the resonating structure. It shows a resonance, right? So what happens basically? Yeah. To see what happens here, you will see the delocalization of charge, right? Delocalization of charge, and we know that due to the delocalization of charge, यहाँ पे क्या होगा? यहाँ पे CH2 bond and here the positive charge. Similarly, आप इसी तरह आगे भी resonating structure बना के देख सकते हो, right? And you will get that you will get that carbocation is highly stabilized by delocalization of electron, right? So more the delocalization of electron, more the benzene ring on the alpha carbon, right? More the, just remember, more the benzene ring on the alpha carbon, more will be the rate of reaction, right? More the carbocation is stabilized, right? So that's why benzyl में सबसे ज़्यादा होता है, then 3 degree में, then allyl. And yeah, just remember in allylic also you can see the same, because we know that allylic structure, what happened? So the benzene ring, so the X, this is the halogen group. The halogen group is attached to sp3 hybridized carbon, and this sp3 hybridized carbon is attached to sp2 hybridized carbon, right? So carbon carbon double bond. So that's it. That is your allyl halide, right? So again, you can just draw the same structure. What will happen? So here, the CH2, it will form the carbocation, right? Now you can see when you just delocalize this charge, what happens? Here, this will goes here. This charge यहाँ पे आ जाएगा, right? So you will got the resonating, you can say the delocalization of charge you can see over here, right? Due to the double bond, due to the double bond. Okay, so more the double bond, more the double bond and more the benzene ring, more will be the more will be the stabilization of carbocation, and more the stabilization of carbocation, more will be the rate or more will be the reactivity towards SN1 type of reaction, right? So that's why the sequence is benzyl में सबसे ज़्यादा होता है, then 3 degree, then your allyl, and then 2 degree, and then 1 degree. Yeah. So just remember the sequence. Okay. Just write on this the note. Rate of SN1, this is very important, is directly proportional to the number of benzene ring. More the number of benzene ring, more will be the delocalization, more will be the resonance, right? On carbon carbocation, right? A carbocation you can say, or CX. Because when this X will remove, you will get C plus carbocation over here, right? So basically, the rate of SN1 reaction is directly proportional to the number of benzene ring on carbocation or CX bond, right? Or it is also rate of SN1 reaction is also directly proportional to the number of alkyl group on C plus or CX. More the number of alkyl group, more will be the uh, you can say the rate, fast will be the rate of reaction, right? So just remember this sequence. Let's do some question. Write down the question, Monipa. Just tell me which which would undergo SN1 reaction faster. CH3, CH2, Br, suppose it's A, or CH3, C, CH3, and here again CH3, and here Br. This is B. Now just tell me and give me the reason also. Rate of SN1 reaction is directly proportional to, yes,
The number of alkyl group.
A or B. Just tell me which one has the faster.
B.
Yeah, very good. B. B में fast. Why? What is the reason behind that? You can see
It's
more
a 3
alkyl.
degree carbon.
Yeah, it's a 3 degree carbon. When you remove this, it is 3 degree carbocation, right? So 3 degree carbocation में ज़्यादा होता है. So that's why the SN1 reaction is faster in B. Similarly, okay, let it be. I will give you in homework, right? So I will give you this type of, like, arrange the following in the increasing order of the activity towards SN1 type of reaction, SN2 type of reaction.